225 is not equal to 215. Therefore, this is an unbalanced transportation problem. Whereas in assignment problems are said to be unbalanced if the number of rows are not equal to number of columns. That is, if it is not a square matrix. Add plus 2. So we are going to add 2 at the intersection of the lines and subtract all the uncovered values by 2. Hello dear students, welcome to this session of Operation Research OR class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today I am going to discuss very important concept, that is the assignment problem. Before that, let me take one problem on transportation. Now let us solve a problem on unbalanced transportation. Then I will go to the next concept, that is called the assignment problem. Now let me take one problem in unbalanced transportation problem. So solve this unbalanced transportation problem and find the initial basic feasible region. Using least cost method. Which method we are going to apply for this is the least cost method. Now let us check whether it is balanced or unbalanced transportation. So this is a transportation problem. Now let us check here. 100 plus 70, 170 plus 55. 170 plus 55, this is equal to 225. So the supply is equal to 225. Let us verify the demand. 85 plus 35. 85 plus 35 is 120. 120. Again 50 plus 45 is 95. If we add this 5, 9 plus 2 is 11, 215. So this is 215. Demand is equal to 215 and the supply is equal to 225. Here supply is not equal to demand, that is 225 is not equal to 215. Therefore, this is an unbalanced transportation problem. So the given problem is unbalanced transportation problem. Now first, to convert this into a balanced transportation, we are going to add a dummy row or dummy column. Since here 225 is greater than 215, that means the supply is greater than the demand. Therefore, we are going to add one more dummy column with all the entries as 0, 0, 0 and the sum as the difference between these two. 225 minus 215 is equal to 10 with the sum as 10. Now let us add a dummy column. So D5 is a dummy column with entries 0, 0, 0 and the total as sum. So all the elements are 0 except this D5 column. In D5 column we are going to add a dummy 0, 0, 0 with the total 10. If I add this is 225. Again 85 plus 35 plus 50 plus 45 plus 10 is equal to 225. So here supply is equal to demand. 225 is equal to 225. Therefore, this is a balanced transportation problem. Now it is balanced. Now what is the method we are going to apply? The least cost method. As you know how to apply the least cost, just select the least element in the table and proceed. Just find out the least element. Corresponding to that least element, identify the supply and the demand. Select the minimum value in supply and demand and allocate it. That's it. Now here let us consider this is the least value. I will consider this row. In the first row, least element is 0. Here the supply is 10 and the demand is 10. So supply is 70 and the demand is 10. Let us select this element. This is the least element. So what is the supply and demand? Demand is 10 and supply is 70, which is minimum. This is minimum. So I can allocate 10 here. If you subtract this, 10 minus 10 becomes 0. 70 minus 10 is equal to 60. Once if this becomes 0 means we can cancel all the elements in that particular row or column. Now next, select the next least element. Which is the next least element in the table? 1 is the next least element, because here all the zeros gets cancelled and what is left over is 1 is the next least element. Now here just identify the supply and the demand. Here the demand is 35 and the supply is equal to 60. What is the least value? 35 is the least value. So we can allocate 35 here and subtract 35 from this. This becomes 0. Again you can subtract 35 from this. If you subtract 35 from this, what is the remaining you are going to get? This is equal to 25. Now here once if this becomes 0 means we can cancel all the elements. Okay. Now let us identify the next least element. What is the next least element in this table? The next least element is 2. 2 is the next least element. Here this 2, for this 2 the demand is 50 and the supply is equal to 55. What is the least value? This is the least value. We can allocate 50 here, 50, and subtract 50 here. This becomes 0. If you subtract 50, you will get 5. Once if this becomes 0 means we can cancel all the elements. Okay. So see here, the next least element is 2. For this 2, the demand is 50 and the supply is equal to 55. Minimum value is 50. We can allocate 50 here, and 50 minus 50 is 0. 55 minus 50 is 5. If this becomes 0 means we can cancel the elements. Now identify the next least element. What is the next least element in the table? 3 is the next least element. Here 3 is the next least element. For this, just identify the supply and the demand. The demand is 45 and the supply is equal to 25. The least value is 25. We can allocate 25 here. This becomes 0 and this becomes 25. Yes, 45 minus 25 is equal to 20. If all the values gets cancelled here, so we can cancel, yes, these values. Okay. Next come to the next least element. What is the next least element we have in the table? The next least element is the 6 is the next least element. So once if all the elements in this, if this becomes 0, all the elements in this particular row is cancelled, 6 also gets cancelled. Now identify the next least element. What is the next least element? So here the elements left are 11, 10, then 8 and 7. 7 is the least element. To this 7, what is the minimum value? The demand is 20 and the supply is 100. We can allocate 20 here. So this 20 minus 20 becomes 0. If you remove 20 from this, the remaining is 80. So just if this becomes 0 means we can cancel these elements. Now what is the next least element we have in the table? The next least element is 10. So corresponding to 10, what is the demand and supply? Demand is 85 and the supply is 80. Which is the least value? 80 is the least value. We can allocate 80 here. So you can subtract 80. What you will get? 5 is the remainder. So if you subtract 80 from this, this is equal to 0. Once this becomes 0 means we can cancel all the elements. So everything is already cancelled here. So no need to cancel. Then let's go to the last. The next least element left over is 11. So for this 11, what is the demand? 5. And what is the supply? 5. Supply and demand are same. You can allocate 5 here. 5 minus 5 is 0. Again we can put 5 here. 5 minus 5 is equal to 0. So therefore supply is equal to demand. So it is a balanced transportation problem. Now here in this stage we can find the solution for this. Okay, this is how we are going to allocate. So to find the solution, just identify the cells where we have been allocated. This is one cell. 35 into 1 is the first value. Then the next value is 25 into 3 and 10 into 0. This is second value. And the next value is 5 into 11 and 50 into 2. Then 80 into 10. Then 20 into 7. These are the values. Anything else? So any allocation? So that's it. So 35 into 1, 25 into 3, 10 into 0, 5 into 11 plus 50 into 2, again plus 80 into 10 plus 20 into 7. 1, 2, 3, 4, 5, 6, 7 allocations we have. Now let us identify the solution now. Now the solution is given by, therefore the solution, that is nothing but the cost of the transportation. Solution is nothing but cost of transportation is equal to, just simplify this, 35 into 1 plus 25 into 3 plus 10 into 0 plus 5 into 11 plus 50 into 2, then plus 80 into 10 plus 20 into 7. Totally how many allocations? 1, 2, 3, 4, 5, 6, 7. So this is 35 into 1 is 35, 25 into 3 is 75, 10 into 0 is 0, 11 into 5 is 55, plus 50 into 2 is 100, plus 80 into 10 is 800, plus 20 into 7 is 140. Let us add this. 35 plus 75 plus 55, that is equal to 165, plus 100 plus 800 plus the 140 is nothing but 900, 1040. So if I add these to 1040 plus 165, so 165 plus 1040, if we add, how much we will get? 1205. The cost of the transportation is, therefore, the cost of transportation is equal to rupees 1205. So this is how we are going to solve a transportation problem using least cost method, if it is a balanced or a unbalanced. If it is a balanced, straight away we can go for the method. If it is an unbalanced, just use the dummy row or dummy column and solve. That's all. So that's regarding a problem based on the transportation. Now let us come to the next concept, that is called assignment problem. So in assignment problem, we are going to study very important method, that is called Hungarian method. Now before that, let us know what is meant by a transportation problem. So here we are going to assign a particular job for a particular person depending upon the capability. So here assignment problem is a special case of transportation problem where the object is assigned to each source to each destination, just assigning a problem from each source to the destination. So in other words, the assignment problems involves matching of every origin with one particular endpoint so as to minimize the cost or to get the maximize the profit, to get minimum cost and to get the maximum profit. So as to minimize the cost or maximize the profit, we are going to assign for a particular job or a particular person. That is called as the assignment method. That is called an assignment problem. Now, so what is the difference between assignment and the transportation problem? Let us know the difference between the transportation problem and the assignment problem. Now let us know the difference between the transportation and assignment problem. So in transportation problem, this is about reducing the cost or improving the profit involved in the transportation. So in transportation problem, the intention is to reduce the cost or to improve. In transportation problem, it is to reduce the cost or improving the profit involved in the transportation. Whereas in the assignment, this is about assigning finite source to finite destination in a way where only the destination is allowed to one source. Here the allocation, just assigning the finite source, to the finite destination in a way that only one destination is allotted to one source. One destination is allotted to one source. So here is nothing but assigning finite source to the finite destination. Here about reducing or improving the profit in this transportation. Whereas in transportation problem, number of sources and the number of destination need not be equal. That is, it should not be a square matrix. It may be a square matrix or may not be a square matrix. The number of sources and the number of destinations are not equal in transportation problem. That means the given problem may not be a square matrix. Number of rows is not equal to number of columns. Whereas in assignment problem, the number of source and the number of destination must be equal. That means the given problem is a square matrix. Number of rows is equal to number of columns. So the number of source and the number of destination must be equal. that is matrix has to be a square matrix to get the solution. Now, whereas in transportation problem, problems are said to be unbalanced if the total demand and the total supply do not match. If the supply and the total demand are not equal, then the problem is said to be unbalanced. Whereas in assignment problems are said to be unbalanced if the number of rows are not equal to number of columns. That is, if it is not a square matrix. If the number of rows are not equal to number of columns, then if it is not a square matrix, then the problem is said to be unbalanced. This is an important concept. So, a transportation problem is said to be an unbalanced if the supply is not equal to the demand. If total supply is not equal to the total demand, then it is called an unbalanced transportation problem. Whereas, if the number of rows is not equal to number of columns, the problem is said to be unbalanced in assignment if the number of rows is not equal to the number of columns. And next, the problems are solved in two stages. The transportation problem can be solved in two stages that we have already studied. The different stages are northwest corner method and least cost method, and then Vogel's approximation method. So, here the very important concept we are going to use and the familiar steps we are going to use are in northwest rule matrix method or matrix minima method or least cost method, that is Vogel's method we are going to use. Now, whereas in assignment problems, we are going to use only one method, that is called the Hungarian method. Problems are solved using Hungarian method. So, these are the difference between the transportation and the assignment problem. So, you may expect this type of question for 5 months. What are the difference between transportation and assignment problems? Okay. Now, let us come to the method of solving this assignment problem. How we are going to solve the assignment problem. Now, types of assignment problem. Now, let us discuss regarding the types of assignment problem. So, the types of assignment problems, as you know, like transportation problem, here also balanced and unbalanced assignment problem. So, unbalanced assignment problem and balanced assignment problems are the two types which we are going to study. As we know what is meant by unbalanced and balanced assignment problem, if the number of rows is equal to number of columns, first we need to check whether we have equal number of rows and equal number of columns. That is, if it is a square matrix, then only we can proceed. Otherwise, then it is said to be a balanced transportation. If it is an unbalanced transportation, we need to convert an unbalanced transportation into a transportation problem by adding either dummy row or dummy column. So, if the number of rows is equal to number of columns, then the assignment problem is said to be a unbalanced assignment problem. This unbalanced assignment problem is to be converted into balanced by adding a dummy row or dummy column, so that the number of rows and number of columns will get reduces to same square matrix. Now, in assignment problem using Hungarian method. So, we can solve this assignment problem using Hungarian method. So, Hungarian method is very important method which we are going to use to solve this assignment problem. So, assignment problem can be easily solved by applying the Hungarian method, which consists of two phases. So, in the first phase, we are going to use row minimization and column minimization, and then scanning of row and column, then finding the optimal solution in the phase 2. So, in phase 1, this consists of two phases. In the first phase, row reduction and row column reductions are carried out. In second phase, the solution is optimized on the iterative basis. Okay. Now, step by step procedure to solve the assignment problem. Step by step procedure. Step by step procedure to solve this assignment problem using Hungarian method. Now, the first step, 0 step, consider the given matrix. Verify whether it is a balanced or unbalanced. In a given problem, if the number of rows is equal to number of column, if number of rows is equal to number of column, then if they are not equal, then we are going to add a dummy row or dummy column. Then the assignment cost for dummy cells are always assigned as a 0. Now, check whether it is a balanced or unbalanced assignment problem. If it is a balanced assignment, we can go for the next step. If it is not balanced, then we are going to add a dummy row or dummy column with always the cells assigned as a 0. In the step 2, reduce the matrix by selecting the smallest elements in each row and subtract with other elements in that row. That is called the row reduction. Go to the row reduction. In row reduction, just select the least element and subtract each and every element of that particular row by the least element. That is called the row reduction. After row reduction, go to the next step, that is called a column reduction. In column reduction, reduce the new matrix column wise using the same method, that is select the least value in that particular column and subtract each and every element by that particular least value. That is called a column reduction. So first find out the row reduction, then go for the column reduction. Then after that go for a row and a column scanning. In row and column scanning, we are going to draw minimum number of lines to cover all the zeros. If the number of lines drawn is equal to order of the matrix, then the optimality is reached. This is very important step. If the number of lines drawn is equal to the order of the matrix, then say for example, if the order is 4 cross 4 and the number of lines drawn is equal to 4, then we can say the optimality is reached. If not, then go to the next step, step number 7. If optimality is not reached, then we will go for the step 6. Now, what is the next step we are going to follow? Select the smallest element of the whole matrix which is not covered. This is very important. Select the smallest element in the whole matrix which is not covered by the line. Subtract this smallest element with all the remaining elements that are not covered. So, we have to subtract all the uncovered elements from the least uncovered value, and that is add the value of x, that is as x, or add the values of x at the intersection of the lines. So, add the elements at the intersection of the lines, leave the elements covered by the single line as it. Then we will go for the next step. So, just what is the important step here 6 is just if it is not optimized, then find out the least uncovered value as x and subtract all the uncovered values by the least element, and whereas at the intersection of the lines add the value of x. That's it. Now then go for the next step. Take any row or column which has single zero and assign by squaring it. Then strike off the remaining zero if any in that row and column. Repeat the process until the assignment has been made. The process is repeated. Then the final step is write down the assignment result and find the minimum cost or the minimum time. So this is how we are going to solve a problem using Hungarian method for an assignment problem. So I can explain this while solving the problem. Let me take an example. Now let us come to the problem. Solve the following assignment problem using Hungarian method. The matrix represents the processing cost. This is very important. So the processing cost is represented in the form of a matrix. We have to solve this by an Hungarian method. Now just find out whether this is a balanced or unbalanced problem. So what is the order here? This contains 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5 columns. So the order is 5 into 5. M cross n is equal to 5 into 5. Number of rows are 5 and the number of columns are 5. Now the first method is row minimization. Row minimization is nothing but just identify the least element in this particular row. In row 1, in row A, the least value is 2. Subtract each and every element by 2. That is 10 minus 2, 3 minus 2, 3 minus 2, 2 minus 2 and 8 minus 2. And similarly go to the next row. In the next row the least value is 2. You can subtract each and every element by 2. Whereas in the third row the least element is 2. Subtract each and every element by 2. Similarly in the third row the least element is 2. Subtract each and every element by 2. And in the last row the least element is 6. Subtract each and every element by 6. Okay. So if I subtract 2 from this, minus 2, minus 2, minus 2, minus 2 and minus 6. What are the elements we are going to get? 10 minus 2 is 8, 3 minus 2 is 1, 3 minus 2 is 1, 2 minus 2 is 0, 8 minus 2 is equal to 6. Similarly, 9 minus 2 is 7, 7 minus 2 is 5, 8 minus 2 is 6, 2 minus 2 is 0, 7 minus 2 is 5. So just go on subtracting. What are the elements we are going to get here? 8. See, 10 minus 2 is 8, 3 minus 3, 3 minus 2, 3 minus 2 is 1, 1, 2 minus 2 is 0 and 6. These are the elements we are going to get after subtracting each ever element by 2, 2, 2. And the last 9 minus 6, 9 minus 6 is 3. Again 10 minus 6 is 4. Again 9 minus 6 is 3. Again 6 minus 6 is 0. 10 minus 6 is equal to. This is called a row minimization. Now come to the column minimization. Now in this row minimized matrix, let us find out the column minimization. For column minimization, in this row minimized matrix, come to the first column. In the first column, what is the minimum value? 1. Just subtract each and every element by 1. So 8 minus 1, 8 minus 1 is 7, 7 minus 1 is 6, 5 minus 1 is 4, 1 minus 1 is 0 and 3 minus 1 is 2. Okay, now come to the second row. In the second row, what is the minimum value? Again here 1 is the minimum value. Again subtract each and every element by 1. So 1 minus 1 is 0. Again 5 minus 1 is 4. 3 minus 1 is equal to 2. 3 minus 1 is equal to 2. And again 4 minus 1 is equal to 3. Now come to this. Again what is the minimum in this? 1 is the minimum value. You can subtract 1. 1 minus 1 is 0. 6 minus 1 is 5. Again 4 minus 1 is 3. 6 minus 1 is 5 and 3 minus 1 is 2. Again the minimum value is 0 here. So if you subtract anything from 0, you will get the same 0, 0, 0, no change. And the last, in the last column, the minimum value is 2. There are two minimum values. You can consider any one. So 6 minus 2. 6 minus 2 is 4. 5 minus 2 is 3. 2 minus 2 is 0. Again 2 minus 2 is 0. 4 minus 2 is 2. So this is called the column minimized matrix. Column minimized. This is row minimized. So just find out row minimize and column minimization. Now after row and column minimization, go for the scanning. First go for row scanning, then column scanning. That's it. Now let us come to the row scanning. From this column minimized matrix, we will do the row scanning as well as the column scanning. Now let us come to the row scanning. Now let me write all these elements as usual. 7, 0, 0. I will write all the elements. 7, 0, 0. Again 0, 4. Then 6, 4, 5. 6, 4, 5. 0, 3. Then 4, 2, 3. 4, 2, 3, 0, 0. Again 0, 2, 5. 0, 2, 5, 0, 0. 0, 2, 5, 0, 0. 2, 3. 2, 3, 2, 0, 2. So this is the matrix from this column minimization as well as row minimization. Now from this, let us go to the row scanning. Row scanning here. Here what is the row scanning? We are going to get identify the zeros. In the first row, just identify the row number of rows. If 1 0, just circle this. If it is more than 1 0, go for the next row. That's all. So that is called row scanning. Now in row scanning, now come to row scanning. So here the number of zeros are more. So we can leave this. Here come to this row 2. Here the number of 0 is only 1 0. While scanning the row, so we are scanning row scanning. We are doing row scanning. While scanning the row, we can cancel the column. This column is cancelled. Okay. Now come to the next row. In the next row, we have 1 0. Box this. We are doing row scanning. We can cancel this column. This column is also get cancelled. And next here 1 0 is there. You can box this. Since we are scanning the row, we can cancel this column also. Here no. So this is called a row scanning. Now come to the column scanning. So same elements I will take 0, 0, 0, 4, again 6, 4, 5, 0, 3, again 4, 2, 3, 0, 0, again 0, 2, 5, 0, 0, again 2, 3, 2, 0, 2. Now, so what are the rows we have cancelled? J1, then J4 and J5. Here we have boxed this, then D, then B is gone, then C, 3 lines. Now come to the column scanning. So in column scanning, just come to the first column. First column is already cancelled. Go to the second column. In second column, there is 1 0. This is 1 0. You can mark this. Once if the column is scanned, we will cancel that particular row. So this row is cancelled. Okay. Now come to this column. There are no zeros. Here also they are cancelled. Now just identify the number of lines drawn. How many lines we have drawn? This is 1, 2, 3, 3 vertical lines, 1 horizontal line. So the number of lines drawn is equal to 4. But what is the order? Order is equal to 5. So here 5 is not equal to 4. So 5 is not equal to 4. Then the optimality is not reached. We have to go for the next step. In the next step, what is the next step? Identify the least value which is not covered. Identify the least uncovered value. Call it as x. Here, what is the value of x? Find out the least uncovered value. Which is the least uncovered value here? Here, the least uncovered value is 2. 2 is the least uncovered value. You can take any value. This is the least uncovered value. X is equal to 2. Okay. Now, just subtract all the uncovered values by 2. Just subtract 2 in all the uncovered values except at the intersection of the line. At the intersection of the lines, just add 2. Okay, this is very important. Hope you followed. At the intersection of the line, add plus 2. At non-intersection uncovered values, for uncovered values, subtract 2. That's all. So here subtract 2, 4 minus 2, 5 minus 2, 2 minus 2, 3 minus 2, 2 minus 2, 5 minus 2, 3 minus 2 and 5, 2 minus 2. And at the intersection of the lines, we are going to add. Now next, I will go to the next where we are going to add. Here the intersection, here we are going to add plus 2. Plus 2 for this. Again here also it is intersection, plus 2 we are going to add. 7 plus 2, 9, 4 plus 2, 6. Next, nothing, only 2 places. At all these remaining places, we are going to subtract 2. That's it. Okay. Now, let's go to the next table. A, B, C, D, E. Okay. J1, J2, J3, J4 and J5. Now let me draw the lines. Now write down the values. So here 7 plus 2 is 9 because we are adding plus 2 there. The remaining are same, 0, 0, 0, 4 plus 2. So 0, 0, 0, 4 plus 2 is 6. Okay. Now again here 6 as it is, and here we are going to subtract minus 2, minus 2. 4 minus 2 is 2, 5 minus 2 is 3. 2 and 3, then 0 as it is, and 3 is also as it is. 0 and 3 as it is. Okay. Now let's come to this. 4 as it is, you can subtract 2 here, you can subtract 2 here. So 4, 2 minus 2 is 0, 4, 0, 3 minus 2 is 1, 0, 0, 1, 0, 0. Okay. Now let us come to the next. 0, you can subtract 2 here, minus 2, 0, 2 minus 2 is 0, 5 minus 2 is 3, 0, 0, 2, 3, then 0, 0. Right. And the last 3 minus 2, 2 minus 2, 2, 0, 0, 0, 2, 2, 0, 0, 2, sorry, 3 minus 1 is 1, 3 minus 2 is 1, not 0. Now let us come to the last row. In the last row, what we have? So 2 as it is, 3 minus 2 is 1, 2, 1, then 2 minus 2 is 0, 0, 0 and 2 as it is. So these are the values. Now where we have encircled the circles, identify those values. So here it is 1, 0 and here it is 0, here it is 0, here it is 0. Okay. Now let me explain once again. After this, since this 2 minus 2 becomes 0, we can consider this as the final element. So you can cancel this 0 also. So this gets cancelled. Now the remaining cancel rows are, we have cancelled this J2, then in here it is J4 and again in C it is J5, again in D it is J1, in D it is J1 and in E we have J3. So see here you can see the number of rows we have encircled, the number of rows we have cancelled is 1, 2, 3, 4 and 5. So the order is equal to 5 cross 5 and the number of lines we have drawn is also 5. So order is equal to number of lines. So therefore it is optimized. The optimality is reached here. So we can find out the assignment now here. Now what is the assignment we are going to do? From here J2 to A and again J4 to B and again J5 to C and again J1 to D and where is 0 here J3 to E. So just these are the final assignments. So we can assign here, that is J2 to A and J4 to B and again J5 to C and again J1 to D and finally J3 to E. Okay. Now let me write it here. So therefore the jobs and the missions. So here job first one is J2. J2 is assigned for A. J2 to A. Next J4 to B. J4 to B. Next one is J5 to C. J5. One is J5 to C. J5 to C. Next 0 is here J1 to D. Then last one J3 to E. See all J1, J2, J3, J4, J5 are assigned. Find out the values. Just substitute the values from the given table. That's it. Now substitute these values. What is the values we are going to get? J2 to A. J2 to A is nothing but 3. It is 3. Okay. Next J4 to B. Yes. J4 to B it is 2. Then J5 to C. J5 to C it is 4. Then J1 to D. J1 to D it is 3. Then J3 to E. J3 to E is 9. Now add this. So 9 plus 3 is 12. 9 plus 3 is 12. 12 plus 4 is 16. 16 plus 2, 16. 17, 18. 18 plus 3 is 21. So this total is equal to 21. So therefore the total minimum cost is 21. Therefore the total minimum cost is equal to 21. So therefore the total cost, minimum cost, therefore I can write here total minimum cost is equal to rupees 21. That's it. The total minimum cost is rupees 21. This is how we are going to solve a assignment problem using Hungarian method. Very simple, but the steps are more. Just check whether it is a balanced or unbalanced. If it is a balanced problem, you can straight away go to the row scanning and column scanning. that is first row minimization, then column minimization, then row scanning, column scanning, identify the number of zeros and just go on cancelling. Then if the number of lines drawn is equal to the order, then the assignment is completed. If it is not, go for the next step, that is just select the least uncovered value as x and subtract with that x at the uncovered values and add that x at the intersection of the lines. Then repeat the process until you will get the number of rows and columns is equal to the number of lines, number of zeros identified. Then you can assign and get the solution. That is the procedure. That's it. So this is how we are going to solve. So that's regarding this session. Let us meet with different problems in the next session. Thank you.